Welcome to the first video of Module 2. In the last module, we had a brief introduction to what photogrammetry is, how it works, and how it can be used. Now we will get into the practicalities around using the process. Like any tool, photogrammetry is great at performing some tasks and bad at others. In this module, we will focus on the strengths of photogrammetry and how they can best serve you and your storytelling needs. In this video, we will also consider photogrammetry in terms of the end result medium. In other words, do you want to create a story told using a 3D medium like virtual reality or augmented reality? Or do you want to use photogrammetry to produce media for a story told in 2 dimensions? For example, as a video piece or as images used in a website. Like any powerful tool, photogrammetry is very flexible and is limited only by your imagination and some critical technical limitations that will determine whether or not photogrammetry will work for you at all. So let's start there and talk about when photogrammetry does not work. First and foremost, your capture subject must be a static object. Unless you are using a complicated capture system, photogrammetry will only work if the subject matter you are capturing is motionless. For example, you can capture a cat if the cat is asleep, but if the cat is walking, you cannot capture the cat with photogrammetry. The reason for this is that photogrammetric capture depends on capturing a subject from all perspectives so that the software can identify common points that haven't moved in space from image to image. If you try to photogrammetrically capture your sleeping cat and your cat moves its leg, the common points on the leg that moved will have changed, and the software will become confused by that change in the common points and where they are. And it will likely fail to reconstruct your cat, or the software will create a sort of strange abstraction, 3D abstraction of your cat. So always make sure your capture subject will not move. I cannot stress this enough. But many static objects still will not photogrammetrically reconstruct because of the material surfaces of the object. For example, here's a white glazed coffee mug. It is smooth, a solid color, and kind of shiny. The surface lacks a strong texture. It's relatively featureless. Photogrammetry software will also struggle to see this kind of material. Here's a French press. It's made of human-made black plastic with a clear plastic vessel. Again, the features are smooth and relatively featureless. The software mostly fails to reconstruct the clear plastic vessel, which is transparent, except for where the text is and perhaps some of the mineral water stains left behind. So the software, photogrammetry software, has trouble seeing, as it were, smooth, reflective, shiny, and clear material surfaces. Many synthetic human-made objects have these kinds of material and texture characteristics. So glass windows, mirrors, television screen, plastic objects, metals, lots of metals. On the other hand, organic materials often work well for photogrammetry. This ancient marble head of Medusa with its rough texture is like a rock and is an easy candidate for capture. It's rough and kind of multicolored. Wood, rock, concrete, and fabric, like on a shoe, will also work well. The fabric and these materials have a texture to them, and in many cases different colors exist. Now, liquid water is a substance that does very poorly for photogrammetry capture. It's usually in motion, and even if the surface is perfectly still, it will likely be reflective and or often has a level of transparency or a flat color to it, either of which will also spoil your capture. So while organic capture-friendly material textures may seem like limitations, they actually underscore the value of photogrammetry, which is capturing objects that have very visual imperfections and blemishes. This is the authenticity that a photogrammetric 3D model reconstruction provides. It's difficult to fake this kind of real-world wear and tear when creating a 3D model from scratch in software. Now, when thinking about whether or not photogrammetry is going to work for you, it's important to think about the materials of the objects you wish to capture. When materials don't capture well, you have to rely on 3D modeling skills to repair the damaged reconstruction, in which case it might make more sense to just 3D model the object entirely. Now, once you've determined whether or not your story has an object that it is possible to photogrammetrically reconstruct, The next question in determining the viability of using photogrammetry in your project is considering how you want to deliver your content to your audience. There are two basic outputs of the photogrammetric reconstruction. One is a 3D model, which most journalistic applications of photogrammetry result in, say, a 3D VR experience or an augmented reality experience or some kind of 3D story that uses 3D models. But a 3D model could also be brought into Google Earth for creating two-dimensional video outputs, where you take advantage of the high-resolution imagery that drone-based photogrammetry can provide over the built-in satellite imagery that Google Earth provides. Or you could create a two-dimensional video fly-through of your 3D model. This could even be done by having a person walk around inside a virtual reality experience while their perspective is recorded as a 2D video. Or you could export an orthomosaic map, which is commonly used by surveyors for creating two-dimensional representations of three-dimensional landscapes. Every time you look at Google Earth or Google Maps satellite data, you are looking at an orthomosaic, at a map. The imagery of an orthomosaic is consistently scaled and accurate, which is why you can determine, for example, the driving distance between point A and point B. So as you can see, there are many ways of using a photogrammetric reconstruction and the results of that reconstruction for visual storytelling, if you work within the materials and zero motion, static motion constraints of the process.